Going on now to the last topic in Math 1108, topic 2 of Chapter 10, Measures of Center. Well, one of the things we often try to do is figure out what is typical of an outcome. And we often think of this as like, what's in the center of it? And that gives rise to one of our first terms here that you're probably familiar with, and that is mean. What is the mean of something? And it's often referred to as the arithmetic mean. And another common word for this is, what is the average? Well, for this, and you may recall this from arithmetic, that if we take the number of items, for instance, test scores, and these would be the various test scores, and they would be n in number, and we add them all together. And for this, we use the Greek connotation, this Greek sign referred to as sigma, which is the sum. And we say the sigma, the sum of all of these test scores, and then you're going to divide it by the number of test score items. So if you had 12 tests, then the sum of all your test scores divided by 12, that would be your arithmetic mean, or as we often refer to, the average. But the formal word here we're using, of course, is mean. So the official rule of it, in a sense, for the mean, and we often use the symbol X bar as a shortcut to what the mean or average is the sum of all the scores divided by the number of scores, and that gives you the arithmetic mean. Now, some calculators can do this, and of course, I don't believe yours does. So, looking at an example 1 here, here are the results of companies' profits for these years, and these are the profits. So we just take these scores, add them together, and there were 5 scores in a sense. We divide by 5, and we get the average then is this. A good thing too would be to, practice using these symbols, X bar as the symbol for the arithmetic mean, so that gives you a little practice with them. Going back to what we did in the previous section where we talked about frequency distribution, here we have some values, and this is the number of times we had that value, twice, and this one 4 times, and so on. So we had a total then of 20 values, even though they're only listed this few times here. But if we wanted to find the mean of this, we'd have to modify it a little bit, because we say the 84 is used twice. So as we set it up down here, we put that in parentheses, 84 times 2, the 87 times 4, 88 times 7. So now when we take our average, our mean, we get these scores, and it's divided by 20. and we get then an average of 90.05. So another example would be, let's say, an instructor of a finite mathematics class collected the age of her students. And the age here is 18, and there were 12 of them. So again, you would multiply the age times the frequency. 19 as an age, there were 9 students. 25, 21, 2, 22, 2. So you then get your total, and then the number of items were 30. So to figure your arithmetic mean, your total divided by the number of items, and you end up with an average age then of 19.1 years. Again, you're looking for central tendency. What's in the center of the data? And one of the ways, of course, is to find the average, or the more formal way, the arithmetic mean. Going back into topic 10.1, when we were working with frequency distribution and laying out that data in a slightly different way, and we're looking for the midpoints of our data. So between 1.0 and 1.4, the midpoint would be 1.2, and here would be 1.7, and so on. And you recall for that first group there were a frequency of 4. So if you multiplied 4 by the midpoint, you would get this. Now there were no values in that second category, you may recall. So multiplying this by 0, of course, you get 0. And again, so on and so forth. So you end up with a total of 132 divided by 40. So you end up with an arithmetic mean for this as 3.3. And you might say, well, how accurate is that? Because we were like averaging the averages, so to speak. And they say sometimes information can be lost, so you may be better off with just the average. Again, this is a sampling, and it may not have, you don't get better accuracy, and it may not be worth the effort of trying to get all the original data when you can just sort of shoot for the trend of what you're getting as opposed to anything in particular. Anyway, that's what they're saying here. So another rule, but this one now of grouped distribution, because this F that we've added here indicates the frequency of a particular item, and then once again by the total number of items that you're dealing with in your data. But we're using midpoints. Alright, so it says the mean of a random sample is a random variable. And for this reason, it is sometimes called the sample mean. Remember, you're not dealing with the whole population. You are taking a sample, and each time you get various samples, and hopefully, because of the large numbers, we mentioned this before, the law of averages, that you get a pretty good idea of what the mean of the group you're studying is. And they go on to develop this a little bit more. We didn't do topic 9.1, but they want to mention here that sometimes the expected value of something, which is called the population mean, and they use the Greek symbol mu, that the expected value would equal mu. And that's what they're showing here. Now, if you had considered another grouping of 40 community colleges, you might find, again, the mean would be 3.3, but another might have been 3.4. But notice that 3.3, 3.4, you're in the close neighborhood. So as we look at data, what does your data report? What is it to be used for? What is the level of accuracy? These are all things you would take into account as you develop your presentation of the statistical evidence, so to speak. All right, let's go on to another term here, the median now. And you may have heard this word before. It's actually the middle. Now, we have the average, which is done arithmetically, adding them all up and dividing by the number. Now, when we look at the median of something, it's the middle entry. So you take a group of items, let's say these numbers here, and the first thing you do if you're looking for the median is to put them in order. So here this is 1 through 8, so we put it 1, 3, 4, 7, 8. These are now rated and put in order. And now we look, what is our middle member? Well, since there's 1, 2, 3, 4, 5, if you go to the third item, that is your median. Now, this is good if you have an odd number of entries. You just pick out the middle. Now, if you have an even number of entries, 1, 2, 3, 4, 5, 6, there's going to be 2 that are sort of in the center, and we find them, or that, by averaging the 2 items, divide by 2, and then that will give you the median. All right, so nicely explained here to give you the vocabulary and the background. If we have odd, we just pick out the middle entry. If they're even, again, you have to put them in order first. Then you find the 2 that are in the middle, add them together, divide by 2. For example 4, they want to find the median number of hours worked per week. Here we have a sample of 7 male students whose work hours were these. Now notice these are in order. So you would have 7, so the middle one is 4. So 20 is the median for this amount of data. Now keep in mind that's not the arithmetic mean. If you were to add these up and divide by 7, you probably would not get 20. But again, we're not looking for that. We're looking for the median, the middle number. And for sample B, we have 11. Again, here the values are not ordered. You need to put them in order. And then with 11, you're going to count to 1, 2, 3, 4, 5, the 6th member. So there would be 5 on each side of it. Your median for that group is 23 hours. In example C now, we have 10 students, which is an even number. And again, once we've put the data in order, we're going to go to our two middle, add those two together, because there's 4 on this side now and 4 on that side. Add these together, and we get the median then, after we divide by 2, of 19. And again, order is important, so data must be arranged before you locate the median. Now, as you interpret the data, and again, these are examples of statistics. We had the mean, and we now have the median, but sometimes the median gives you a better, truer representation of the data than the mean does. You might say, well, what is this? Well, suppose there is a company and there's an office, and in the office there are 10 salespeople, 4 secretaries, the sales manager, and of course the owner. And they get salaries. Well, for support staff, it's $30,000, salespeople $50,000, manager $70,000. But now you include the owner, $400,000. So if you were to figure the mean salary, it would be this. But that's because you have, in a sense, skewed the data by including this very, very large salary of the owner. We sometimes think of this as the outlier, someone who's way outside of it. It's been skewed. But if you were to put these in an ordered pattern, you would find out that the median would be around 50,000 as opposed to the mean of 68,000. So these salespeople, of course, are sort of where the mean of the company would be. Okay, so that's just something to look at when you are interpreting your statistical data. What was included and what does it mean? All right, going on now to the last of the 3 terms, mean, median, and mode. They all start with an M, so rather challenging. But it's an easy one. And generally, the mode is, in your series of data, what score, what data item is most frequent. So find the mode of the given data set. So let's just scan it here, 55. And the one that occurs more often here, 65, 65, 65. So of our data, the 65 is what occurs most frequently. So for this set of data, the mode is 65. And for letter B, as we look at it, we see 220, 220, and we see 240 and 240. So we see the only one that's repeated, and the one that's repeated is the 220 and the 240, and they're both twice. So we refer to this as there's not a single mode, but there are two modes, numbers repeated most often. So this is two modes, or a more formal way, it is bimodal, bi being the prefix for two. And then when we look at letter C, there isn't a price that is repeated, so this is no mode. So again, something easy. The mode is the item that has the greatest number of times that something is used. And here we saw 1, here we saw 2, and this one none. In this little summation, they mention the various advantages of the mode. It's very easy to pick out. It does tell us that sometimes the mean is most common to measure center, but it can be skewed when you have, what you are including in your data. That's sometimes remedied by eliminating the top one and the low one. I know teachers do this. If there's a super high one and all the others are lower, they may throw the high one out and they may throw the low one out. All right, let's go on to example 6. So here we're working with 10 adults. How many hours did they work last week? We have the data. They want you to find the mean. So we'll do that by taking the sum of all the hours and dividing it by 10. And this gives us our mean, arithmetic mean, our average hours worked. And they want to find the median. So once they are put in order, they're not in order here, you'd have to put them in order, the middle number, and you'd have to have, the middle number is actually a 40 and a 40, so when you do add them together you get an 80, divide by 2, it's 40. And 40 occurs more than any other, so 40 is the mode. Okay, well, this wraps up the course. You have your booklet, you'll have your study plan, and you'll have your chapter test, and of course we'll be getting ready for the final.